When is it?
June 13.
Yes.
July, sorry, July.
July. Okay, Esther. Kalau tak pengsan kita, Esther.
Maybe
It's
July.
going to be tomorrow. Okay. So it's on 13th July. So just make sure you prepare for the final exam. It's going to be like a month from now, right? So I think if you really understand the concept, you really follow the classes, I think it will be all right. Okay. So let's continue with our chapter 10, right? So it's on the chi-square test, right? This is quite popular actually, this chapter, especially in terms of one of the statistical tools that can be used for your data analysis, especially for the social science people, right? So let me share, right, again, right, the slides. So, chapter 10 is actually on the chi-square test or the test, this chi-square test, all right? We don't say chi, but chi, all right? So, the test is also known as test of independence. So, what does it mean by test of independence? It means that you have two variables and you would like to check whether these two variables, they are depend on each other or not. Okay, so they need each other or not. So that's what it means by test of independence, right? So let me tell you the overview of data analysis, all right? So I actually have learned quite a lot, right, for this class, and you are ready for your final exam questions, all right? So this overview of data analysis, when we talk about data analysis, all right, for PSM or FYP level, they will be divided in three categories or three objective. Okay, so what do we need in our data analysis? The first one, we call it as descriptive analysis, right? So the analysis only for the descriptive, just to tell you, you know, the overall of the data, the pattern, the trend, what can you find, you know, for example, from the mean, the mode, median, and so on, right? And then the next one, our purpose is to compare means, right? So when I say compare means, so we already actually we have learned three types of sorry, yeah, two types of comparing means. Sorry, three, yeah, three. Right. The first one, we have two sample independent, two independent samples, right? And then we use t-test, and then we also have t-test. Okay, let me write this way, t-test. And then for two, um, okay. T-test, let me write it this way. And two independent samples. And then t-test, we have two dependent samples. And we also have learned about ANOVA when we have more than two independent samples. And then the last part of the data analysis will be to find the relationship and association. Right? Okay, people, please listen. What I want you to do, okay, at the back of your book, right? Dekat belakang sekali, there's an empty space page here. So what I want you to do, I would like you to draw this flow chart, right? Maybe what you can do, instead of doing it vertically, you can write it horizontally. Macam mana ni? Nampak tak? Okay, something like this. So you can draw, because I'm going to give you more information after this, so you can write everything. So when you want to do your FYP, so you can refer to this page. Right? So our data analysis, okay, for FYP, Even for the when you want to do your master's degree or PhD, so it will be the same, right? So data analysis, basically we can divide into three parts. The first part, when we want to just do to analyze descriptively, and then we want to compare means, and the last one, relationship or association, right? So what you have learned this one, you have also learned this one. Starting from today, we are going to learn this part right here, the relationship and association, right? So let me review and summarize again. Okay, so the descriptive is very easy, very simple. And then again, when we say we want to compare means, all right, so the means should be come from the qualitative, quantitative data, right? So it means that whatever you want to compare, right? So the data should be quantitative. So as I said before, we have t-test, right, for two dependent sample, tukar-tukar set, okay, right? So, and then, okay, and then we have another one, t-test, but two independent sample, right? And then we have ANOVA, more than two independent samples, right? So remember, the data must be quantitative. So what does it mean? So this one, remember, we have two samples, right? So let's say this one before and after. And then we have male and female, for example. And then we have more than two independent samples, more than two independent samples. So it can be UTM, UKM, and USM, for example, right? Right, next one. After, remember, compare means now we want to learn another tools of doing the data analysis, which is for relationship and association. So the relationship and association is divided, I can divide it into two parts, right? So remember, when we say relationship or association, it must involve more than two variables. Okay, so it means that I cannot have my relationship with my own self. So it's very, very illogical. Okay, so I always say I have a relationship between me and her, she and I, for example. So the relationship must involve more than two people, more than two variables. Okay, so the first relationship I can say is between um, qualitative, quali and qualitative data, right, or variable. So it means that we have two quali variable, and we want to find the relationship or association. So if quali versus quali, usually I call it association, right? Because when I see what is the association between gender and also subjects of subjects taken by students. So subject is nominal, gender is nominal. So I cannot say if the gender is very high, then more people will take, more people will take, for example, science classes. Okay, I cannot say like that, right? Because we don't have exactly number to measure the qualitative variable, right? So the next one is quanti versus quanti, right? So I give example just now. Yeah, this one, for example, I can say gender versus disagreement. Okay, level of disagreement. And quantity versus quantity. So I call this one relationship because I can see exactly how much variable A is affected by variable B, right? So for examples, sales, okay, in ringgit Malaysia versus, okay, bonus, right? Okay, also in ringgit Malaysia, for example. I can say sales versus, how many days the sales is made, for example, also can, as long as both of the variables should be quantitative, right? So for the quantity versus quantity, so we are going to learn this one, also known as correlation, right? Relationship or correlation, right? So and then we are going to learn this one. If we have two, right? Okay, if we have two variables, then we can use correlation, and we can also use simple linear regression. We are going to learn all this. And if we have more than two variables, so we need to use multiple linear regression. And then also we can use partial correlation. Right. So basically, this is what we need to do in these 3 weeks, right? So we need to learn something on relationship or association. So, but today we are going to learn the first part of relationship. So which is for quali versus quali. So we are going to learn this one. This is what we call it as chi-square test. Right, I give you 2 minutes, all right, for you to copy this one down and to understand what you are writing. Okay, 2 minutes. Okay, are you done, guys? All right. Okay, all right. I can see a few people already finished jotting all this down, and also I really hope that you can understand what you have written. All right. Okay, so today we are going to concentrate on this one, this chi-square test, all right? So hopefully we can finish it this today by today. And then we will going to continue with our correlation and simple linear regression in our next week. And the last week we are going to focus on this multiple linear regression. Right, chi-square test, right? So chi-square test is also known as non-parametric test, okay, non-parametric. So what does it mean by non-parametric? It means that this test doesn't have the variables do not have any parameter. Okay, so when I say parameter, we already learned this word parameter is actually the values that belong to the population. So what is the example of parameter that we have learned so far? For example, mu, sigma, sigma square, right? Those are parameter, right? So in this case, when we want to calculate the mean, the standard deviation, and also the variance, we need quantitative data, right? So we have need numbers to add, to sum, to deduct, and so on. So that's what we call it as parametric test. When the test is parametric, so it has, it is, it has numbers to be computed or calculated. But in our case, chi-square that we are going to learn today is called as non-parametric because it doesn't have parameter. Why? Because it is qualitative data, right? So it is oops, qualitative. Right? So when I say qualitative, right, so it means that we are not dealing with numbers. So for example, we have gender, hobby, and then what else? Agreement, very level of agreement, okay? And then we have what else? Nationality, right? Those are actually qualitative data, and we don't have number to calculate, like to find the mean. We can use calculator in order to calculate the gender. No, we can't. All right. So when we want to check the association between two qualitative variables, then we need to use chi-square test, right? So the data only use frequencies, okay? So we have how many male, how many female, but we don't have scores. When I say scores, we don't have anything that deal with numeric numeric data, right? And then it is suitable to analyze data obtained from Likert scale. Remember, we also learn Likert scale for the ordinal data. So for example, satisfaction level, very satisfied, so not satisfied. Okay, so this one is actually ordinal data, and it is qualitative, right? Okay, so far okay or not? Can you understand what I'm trying to actually explain to you all? Is it okay? Okay, thank you, Tika. All right, and the rest. Okay, thank you, Roha. Thank you, Zian. Okay, so the next one, before we can do our chi-square test, it is very important for us to fulfill the assumptions. Okay, when I say assumptions, it's actually the rule or requirement that we need to fulfill before we can do the chi-square test, right? So the first one, the sampling method is independent random sampling. So what does it mean? When you choose your sample, it should be random. You cannot bias, okay? Cannot be biased. You cannot select only your friends, the one that you know, the one that you love, all right? But it should be random sample. Each population is at least 10 times as large as its respective sample. So what does it mean? If you have 10 samples, right? So it means that you must have 100 in your population, right? So that's what it means. So if you have 20 samples, so it means that you must have 200 population, 10 times as large as its respective sample, right? So the variables are categorical. So categorical means is qualitative variable of data, right? Qualitative. So it can be either nominal or ordinal. And then not more than 20% of the expected frequency count for each cell in the contingency table. We are going to learn this one is at least 5, right? So it means that when we choose people to represent for a certain category, so you must have at least 5 people. You cannot have empty space, or you cannot have no respondents at all for a particular category. Okay, right. So don't worry. Okay, so we are going to learn more, and you will understand better. Right. So let's move on to the next one. Okay, contingency table. So the most important in this chi-square test is actually to develop contingency table. If ANOVA, okay, if ANOVA has ANOVA table, so chi-square also has its own table, which is called as contingency table. So contingency here means probability. So it's probability table. And how it is constructed? In the form of R row and C for column, right? So what does it mean? I'll show you. Actually, you have seen it a lot, okay? But it's just that the glamorous name for that table is contingency table. So for example, we have satisfaction factor is divided into two variables. So we have gender and satisfaction level, right? So, and then this is what we call it as contingency table. Alah, kacang je kan. Pernah tengok. Alright. So you have seen it before. Right. So the contingency table is like this, and most of the students will use this one in their writing, their FYP writing. Okay. So for example, you divide this one, alright, into two. This is the faculty, right? And then this is the gender. So the number here is actually to represent the frequency. Okay, this is what we call it as frequency. Frequency means how many, how often, okay, you see male in this faculty FPPSM. For example, how many female have you can you see in FKE, right? So this number is not score, it's not quantitative data. It's just the number to represent the frequency for each cell. So every single box, this box right here is called cell, right? Kotak ni dipanggil sebagai cell. So in our case, we have 4 cells. 1, 2, 3, 4, right? So the format or the size of this contingency table is represented by R times C. R is the row, C is for the column. So we have 2 rows. So 2 rows, this one, 2, right? And column, we have 1, 2 columns, right? So we have 1, 2, and then we have 1, and then we have 2 rows, right? So that's the reason we say this contingency table is 2 times 2. So people understand, oh, it has, 2 rows and 2 columns. You cannot put it C times R. No, it is standardized, okay? Should be row first and then column. Okay, is everybody okay? Right. So, and then the hypothesis, remember, okay, we have so far different hypotheses for the Z test, T test, and then we also have ANOVA slightly different. And now the hypothesis for the chi-square test will be variable 1, for example, just now, gender, and satisfaction level, okay? So independent. So in our your H naught should be independent. Independent means no association or no relationship. So what does it mean? It means that variable 1 and variable 2 are same, right? So And then HA, variable 1 and variable 2 are dependent to say that there is an association between variable 1 and variable 2. Okay. Right. So people, if you have any question, please ask. Don't just keep quiet. Otherwise, I wouldn't know whether you are okay or not. So if you can see on page 1 to 8, the hypothesis is already examples of the hypothesis. On that page is, for example, H naught job preference is independent of the gender of the university students. Yeah, so the clue word here, right? Sekejap ya, tengah nak belajar something, tak menjadi pula. Okay, anyway, so the clue word here is independent. That's why it is called as in test of independence. Okay, independence test, right? So and then your HA has the word dependent. So the most important you need to remember just for H naught. So H naught needs must have the word independent in it. Right. So what actually we need to do for this chapter, right? So the first thing we need to convert the question in the form, the question to the contingency table. So you need to convert the question to the contingency table, and then you need to calculate something which is called as expected value, which is represented by the letter E, and then you need to calculate the value of this is chi, right? So it's like chi, chi square in a different table. So chi square. So why it is called chi? So this is letter chi, and then this is square, right? Chi square. And then you need to perform 4 steps of hypothesis from the SPSS output. Right. Right. You can see this one on page 129. It's already written there. All right. So you just need to understand what is actually shared on that page. Right. Okay, this is the formula that we need to use, all right? So I'm going to teach you also to calculate manually. So why? Because I want you to understand how the numbers in the SPSS came from, okay? So it's not, you just look at the number in the SPSS output without understanding how the numbers are derived, okay? So it is good for you to understand every single output in the SPSS. Right. There are basically two main formula that we need to use. The first one, we need to calculate the E, which is the expected value. Okay. And then the chi-square, which is the statistical value. All right. And then for the chi-square, we have the DF is R minus 1 times C minus 1. So R is for the row and column for C for the column. Remember, we always have DF, right, is N minus 1. Okay, before this, for the ANOVA, we have DF1 and DF2 because we have two different variations, okay? And then this one for the chi-square because we have row and column. So that's the reason we need to times them, right? So R minus 1, C minus 1. Okay, let's do example, right? So, before that, all right? Before that, okay, on page 129, I think I missed this one. Okay, what does O mean? Right? O means observed value. Okay, what does it mean by observed value? Values that we get from our survey, right? So what we see, what we collect, what we get, all right? So that one is the observed value. Okay, expected value is actually values that we get from statistical formula. So this one on page 129. Okay, so it means that our purpose, for doing this chi-square test is actually we want to compare whether what we get is actually agreed by the statistical formula. Okay, so if whatever we get from our survey not far away from what actually expected by the statistical formula. So it means that our number, our survey, our findings will be okay. All right. So that's what it means. Okay. So let's do first example. Right. So this one on page 130. Okay, we want to do this one. So let's read the question. Among hold on, sekejap ya. Let's continue. Right. So among the most serious problems in schools nowadays are violence and lack of discipline. A random sample of 300 parents was selected, and these parents were asked if they favoring school teachers to public caning students for violence and lack of discipline. Sekarang ni very hard for the teachers to can students in public. So just a few minutes or a few seconds, it will be viral. All right. So the responses of these parents are displayed in the following table. So this is their findings, all right? So this is the data that they have collected. So all the numbers that you see, 93, 87, 70, 32, 12, 6, those are actually the data that we get from the survey, all right? So these are called as observed values. Understand? O, right? So does the sample provide sufficient evidence to conclude that the two attributes, gender and opinions of parents, are dependent? Use a 1% significance level. So you can see the word dependent there. So it means that we want to check the relationship or the association between gender and also opinion. Therefore, we need to use chi-square test. Okay? Is everybody okay? Understand or not? I want you to add one column and also one row and write it as total in the given table, right? The table provided. Just add one more column and one more row for total. Can you please do it now? Okay, Aiman. Okay. Right. Done. The next step, what I want you to do is to draw the same table with the same number of rows and columns below, right? In the space for your answer. but not too big, right? So what I want you to do is actually at the space below, you draw the same table, okay, the same table, and then you divide the page below in two columns, right? Space number one, space number two. So it will be easy for us to answer the question later, right? So you need one more similar table and then divide your page below the table into two columns or two parts, right? Okay, done? All right, thank you. Okay, just the same person over and over and over and over again. Alright, ya, sama Anung, Atika, Aiman, okay, Ziad, okay, who else? Okay, Roha, okay. Now I can see more hands. Alright, so the next step, right, using the original table, okay. So we want, okay, I just want you to write here the letter E, right? So we want to find the values of E for each cell, okay, for each box. Right. Before that, we need to calculate all the total. Okay, for the first one for male, for example. Okay, so we need to add 93 plus 70 plus 12. So, okay, so what do we get? Kaisa, can you give me the answer?
I'm sorry, Doctor, can you repeat?
Okay, can you please add these numbers for me? 93 plus 70 plus 12.
Oh, okay. 175.
One, just read like 175. Okay.
175.
Okay, great. All right. Okay, next one for female. 87 plus 32 plus 6. Okay. Minzen, can you calculate for me? Lee Minzen.
Yes, Doctor.
Okay, can you add these numbers and give me the answer?
125.
Okay, 125. Okay, good. And then 93 plus 8, 7. Alia. Nur Alia Shafira.
180.
180.
Yes.
Okay, next one. Okay. Um, Yi Jin. Ji Yin. Sorry. Ko Ji Yin. What's the answer for this one?
102.
02. And this one, we can calculate this one. Right. Please sum up all this number. What do you get? Anyone? Okay, the grand total.
300, Doctor.
300. Okay, so this number is actually your n, right? So because in the question it says that a random sample of 300 parents. So it means that you must get the total number of the sample 300. So what does it mean? How can we read all this number? So we can see that in our survey, in this survey, 175 males, and then we also have 125 females involved in the survey. And we can also say that most of them agreed, okay, have the level of agreement, okay, because 180 of the respondents say they agree, okay. All right, that one is for the first step, right? So this is what it means by we need to convert, the question into the table, contingency table. Okay, the next one we need to calculate, okay? We need to calculate, so we have this one just now, 175, 125, and then we have 102, 180, 102, and then we have also 18. The total is 300, right? So now we want to calculate. People, please use the same table, all right? The same table, the original table, to write all this information. So we need to calculate the E, and then we need to use this formula right here. R times, this one, R times C divided by N. Okay, I would like you to look this one very, very carefully, right? So how to calculate the E, the value of E. So what does it mean by R? So let's say I would like to calculate for this cell, okay, for this 93. So I want to calculate the E, okay, for row 1, column 1. So this one is E11, row 1, column 1. Okay, so I have R. So which one is my R? Is 175. This number right here. Okay, times, okay, C is this one, the total number of column, right? So 180, right? Divide by N. Okay, N is 300, right? So can someone, okay, I would like to call Zaki Afifi. Can you please calculate this one for me and give me the number, the answer?
Can, Doctor.
Okay, sure.
It will be 105.
105. Is it no decimal point? Exact number?
Yes.
Okay. So people, for the E values, I would like you to write it in bracket. For example, like this 105.0 in bracket under the observed number. So this is your O, this is your E, right? So I would like the next one, okay, to calculate for me this one, Hamdallah, okay, calculate for this one, and then Ziling, okay, Ziling, this one, and then Mingi, Tokni, Mingi, and then I also like Aida. Okay, Aida calculate for this one. And the last one, I would like Priyanka. Okay. So give me the answer, right, for the E. And for the rest of you, you can continue calculate yourself. Don't just wait for your friends. Okay, once you get the answer, let me know. Hamdallah, have you got the answer?
Yes, Dr. Wei.
Anyone? Anyone else? Ziling, Priyanka, Aida.
Yes, doctor.
Okay, Ziling, what do you get?
10.5.
10.5. Is it like
Yes.
this?
Yes, doctor.
Okay, thank you. Okay, friends, please make sure you check the answers are correct or not. Okay, don't just simply rely on your friends. Okay, okay. Anyone else?
Yes,
Okay,
doctor.
Mindy, what do
Doctor.
you get?
7.5.
7.5. Is it like this?
Yes.
Okay, good. Right, next one.
Aida, doctor.
Okay, Ida, yes.
For 2.5.
For 2.5. Like this.
Okay, doctor.
Okay, thank you. Yes, Hamdallah.
59.5.
59.5. Right. Who else? The last one, Priyanka.
Doctor, Priyanka line problem.
Okay,
She give me 7.5.
7.5. Okay, thank you. All right. So people, this is all the E values that we need to calculate based on the statistical formula. Right, so what does it mean? Right, so let's look at the first cell. So from our survey, from the survey, we get 93. But statistics say we should get 105, right? So for example, this one, survey got 12 respondents, but statistics say you only need to have 10 respondents for this particular cell. So that's what it means by O and E. Okay, understand? Right. So once we get these all the numbers, all right? So we have the E. I shouldn't put this way. Okay, let me delete this one. Hold on. Okay, now it's time for us to calculate the chi-square. So we already know the O and E, okay? So for example, just now we have the O and E here, 93 and 105, right? So we have here, it is 300. Oh, sorry, I don't want to write this one. Set. Okay, not this one, sorry. Okay, now we want to calculate for the chi-square. In order to find the chi-square for the first cell, for example, so we have for column 1, row 1, so we have O minus E square divided by O. Sorry, by E. Okay, remember? So this is the formula right here. So how do we get it? So the O is 93, okay, 93 minus 105 square divide by 105. Okay, so we need to get that answer. Okay, people, the number cannot be negative. Your answer cannot be negative. Why cannot be negative? Because this number right here, even it is negative, it need to be squared. So when you square the number, it will be positive. So therefore, during your calculation, when you get any number, negative number, it means that there is something wrong with your calculation and you need to recheck, okay, your answer. Right, so for this one, can someone please give the answer for me? 93 minus 105, what do you get? And then square that number, divide by 105. Okay, Gusti, can you find me the answer? Okay, this one, I want you to use the table that you just draw in at the bottom, all right? Not the original table. Okay, Gusti, can you find me the answer? 1 point
1.37.
like this. Okay. Is it, Gusti?
1.37.
Oh, 1.37. All right. Okay. So people, you may, are wondering, okay, how many decimal points should you keep, in this table? Okay, you can keep as many as you can, but at the end, when it comes to the final answer, you need to get not more than 3 decimal points, all right? Please use not more than 3 decimal points. So you need to round it off. You can use 1, 2, or 3. Right. So next one, Jackie, I want you to find for this one. And then Arif. Okay, Arif. And then also Esther for this one. And then Hasif. Okay. And then the last one, Ramla. Okay, can you please get me the answer?
2.59, Dr. for mine.
2.59.
59.
Okay, thank you, Hasif.
Right, Dr.
Okay. Yes,
Mine
Esther.
is 1.92.
92.
Yeah.
Okay.
Doctor, 0.3.
0.3. Okay.
No, Doctor.
Yes, Arif.
0.21.
21. Okay. Last one from Jackie.
Mine is 1.85.
85. Right. Hasha, what I want you to do, can you sum up all the numbers here? Okay, then we will get our chi-square value.
1.29.
1 point?
3.29.
I cannot hear you, Hasha.
3.29.
2.29.
3.29.
Hah?
Dokter suruh tambah yang mana?
Ni, semua ni. 1.37 plus 1.85. Semua. Itulah saya pun,
Uh, 8.24.
8.24. Right?
Yes.
So this is our chi-square. This is actually the ultimate answer that we are looking for, right? The chi-square value. Right, I stop here for 2 minutes. For those who are still, calculating, still writing, you can finish your writing and then try to understand what we have discussed so far. Okay, is everybody okay? Can we continue now? Right. So now we have done, we have calculated, right? The E, yes, we have done. Because remember, this is the step. So we already done this one. We done this one. We also find the the chi-square values. And the last one is actually to perform the 4 steps of hypothesis test, right? So basically, that's what I want to show you, how the chi-square E values come from. Okay, so at least you know how to get the number, and then when you look at your SPSS output, so it means that, okay, you not just look at it, but you know how the numbers come from. Right. So let's stop. Okay, let's stop. Take a break for 10 minutes, and then we're going to continue with our SPSS. Right. So yeah. It's just that on page 131. Okay, on page 131, I would like you to draw different. We are going, or maybe you can use that space on page 131. Draw this table, right? So as the preparation for our SPSS in 10 minutes, right?